past 4 months basically have been, I'm doing work, Adam, I swear. Like, I do things, really. Like, you want to look at this physics sweep code? You want to look at this this file saving and loading for configuration values? Like, this is really intense gameplay stuff. It's like, no. No. So we're just gonna... Alright, and we are going to multiply this by a factor. We're gonna say this is going to be the float new Dashkin G wall jump Y multiplier. And we're going to set it to 1.0 for now. If that wall multiplier is less than 1, then what's going to happen is you will lose velocity. And if it is greater than 1, you'll gain it. And for this, we're going to have basically, yeah, this just equals velocity, and we're going to do times, we're going to do a wall jump z multiplier. And we also probably want to put in like a wall jump z additive. So we'll do wall jump z add, and we're going to set that at 0. And basically what that's going to be is we multiply the velocity times this wall jump z multiplier. And that's like, well, how fast, you know, how much of your stuff you can do. And then we're also going to add in the current velocity z multiplied by the g wall jump z add. And what that'll mean is basically we can... Yeah, I'll do the same thing with the z. I mean the y. And what that'll allow us to do is we can mess around with it. And we can tune stuff a little bit more, because we're gonna tune the hell out of all these numbers. Like, it's just gonna have to happen. But I'm stoked. That feels really good, and it works well too. Like, that movement is nice. I like how it feels, and I am surprised that I like it when we haven't even touched it for more than just like 2 seconds here today. And it's like, oh, this is cool. Maybe it's nostalgia with, you know, Super Metroid and stuff like that, but still, it's responsive. It's like bam, bam, bam. What the hell? This is cool. I could waste a lot of time doing this bullshit. And that's kind of weird. I don't think we're trying to make a new, you know, innovate incredibly well with. Like, we're not trying to like make the newest platformer with some insane mechanic. With this game, I think with this game we're trying to make a good solid game. You know, somebody would say, well, hey Dashkin, what kind of game is it? Be like, well, it's a speed-based platformer, it has a great story, and it's got great art, you should go play it, it's got great music. They're not going to say, yeah, you should go play it, it's got this insane time-bending mechanic that does all this stuff. It's more going to be, I think, just like, it's a solid game, like, go play it, it's worth playing. At least that's how I see it. Jump and run fun. It's not. We aren't trying to land the space shuttle or something like that. We're trying to you know make a good Brackenwood game. If we're gonna land the space shuttle, like we'd be making that Lemony Wii game or something like that. You'd be playing as her doing like crazy ninja moves. Or whatever, using techno space magic, whatever the hell she uses. I know she's got water or whatever, right? She's like Aqua Girl. this? I'm getting messages. They are unimportant messages. Alright, so let's just double check I didn't multiply something by infinity and blow the hell up the entire world. Though I think we would probably notice if we did. Oh man, and we can wall jump off surfaces that the wall jump off anything. I want to keep that. That's cool. It doesn't have to be just like a surface that sucks. You can just, if you're in the air and you move to the left or right enough, you can get enough to jump. So the question is the landing. So we want to do landing now. I mean sliding on surfaces. So we want to have stuff that the slope of the object is too great. So it's basically the z of the normal is too much. So we're gonna do like landable. I think landable normal z. Right now is 0.1. So why don't we check out? Let's actually make a little test for sliding. We're gonna need a sliding test, aren't we? So let's go ahead and make it. We made one for, the curlicue to test out jumping against the ceiling and how that's gonna work. We need a little slide test for that sec. So let's go build that. So what's this slide test gonna look like? Well, I think what we need is we're gonna want to jump up to this and then slide down, I think. Or maybe we can just like throw it over here. I don't really want to throw it over there. I'll throw it up here. So one of the important things about having a test level is that you can just kind of run through it and like hit all the things real quick in succession. Like that's why we got the stairs, and that's how we caught the bug earlier with like the stairs being all screwed up, right? It wasn't because we were going into trying to test the damn stairs. It was because we got to go over the frickin' stairs to get to the wall jumping area, and it's important when you're making a test level to do stuff like that, because you're not going to want to test everything all the time, and you're not going to go run over and do it if you don't do something in there. So we kind of want to put this thing like right here, and we're going to want to like, if we're running through this stuff, we're probably going to like run over here and then jump through this crap and then jump off of it into like the funnel or something. And that's kind of what we want to do right here. So we want to jump on like a little slide. And what we want to test are a couple cases. We want to test like running along it, and then all of a sudden we no longer should be able to land on it. So like the slope gets real steep real quick while we're moving over it. So let's make that. So we want to actually angle this down kind of slow to start with, I think. I should probably be going a little faster. I should probably go in increments of 10 for the angle. Simple enough. All right, and I think that's steep enough that basically I think Bitey is going to be sliding at this point, so we kind of want to do a little area here where we can kind of slide for a little while. Yeah, it looks about right. And is it this? How do we control shift alt control alt? Yeah, there we go. No, I'm trying to select all these things, not all the rest of this garbage. Alright. If we copy paste this, and then we how do we just like rotate this whole thing? There we go. That looks like yeah, that looks like something else. So we're gonna do that. We don't want people getting the wrong idea about private parts in our test level. So let's go see what we can do right here. So we're just running along. That's how it works right now. So we kind of get to a point where we no longer stick, and then we're kicking off still? I thought we fixed that. Fuck. We fixed that already. We're gonna have to fix it again, aren't we? Alright, so we're going to fix one thing at a time. Before we introduce problems here with this, we need to fix the transition there from ground to air, where all of a sudden it's no longer below us. So let's go see exactly where that is happening. And we're not setting our velocity properly is what's happening. So, like, we're doing our outward nudge. Is this the right one? Update locomotion in the air. No. Attempt mantle. No. So we are no longer on the ground, and our current velocity is I think it's this one. So we'll just double check real quick. Alright, so no, it's actually not here. It's after we move, isn't it? Yeah, so this is where we're setting it. And what is this m wanted velocity? Our wanted velocity is this one. Our current velocity is negative z and all that stuff. So we want to see, like, update locomotion in the air. What are we setting to when we get here? Our new velocity equals our current velocity got zeroed out. How did that happen? Yeah, current velocity got zeroed. Was it with our set physics state? No, it was not with internal set position either. So something else zeroed out our velocity. Our wanted. What's previous velocity? What is our current velocity? Yeah, it's still correct. So sweep one movement location. Okay, so we're traversing a seam, and we're setting our current velocity to sweep one movement direction. What is sweep one? So what's going on here is sweep one normal is the movement sweep collision normal, which got passed in, which is a 1 in the z-axis. Is this another one of those where we've got we're basically on a lip out from the seam that we've landed on? Yeah, it looks like it. Alright, well the thing is, we should, if update snap the floor, it may be what we want to do right here is actually check the return value of snap to floor. And so it's like, if we actually snap to the floor, set the velocity. Otherwise, don't change the velocity from our previous motion. I think that makes sense. Yeah, let's try that out. And we'll do it on the same thing with our obstructed floor path. We're not changing the velocity there, so we should be fine. And we're not changing the velocity here either. The only time we were ever changing this velocity was in this. Alright, so I think we're okay. Simply done. Well, I'm glad it's something as simple as that, where we're like literally just setting it to a seam velocity situation there. We're like, okay, yeah. So we can just be like, oh yeah, well, we're not on the ground anymore. We moved off, so you know, we shouldn't have been moving so far that we hit a yeah, if we hit a tiny lip, literally within that subframe 5 milliseconds, we probably don't want to drastically change our velocity vector. Because it'd be like hitting the tiniest of tiny ramps. You know, like a Hot Wheels car, and there's like a little tiny lip on the end, and you just, bing! All your velocity goes off. I don't think that's too realistic. Yep, that's what we need. It just kind of falls right off there. And the reason... Is it correct? Yeah, we're moving over in that direction because I'm holding the button. If we were slipping, I would expect... Yeah. That is hilarious. You can wall jump up this thing. I want to make it. I want to make it. Damn it. I keep screwing it up. This is like every Let's Play of a platformer ever. And you're just like, I'm trying to, I can do it. And then you just can't quite get the helmet for Mega Man. You're like, fuck. There we go. Alright, that's excellent. So now what we need to do is we need to get him sliding. So the first thing we should do is, if we start traversing this thing, we should just go into the air if the slope gets too steep. Well, let's think about it. How exactly do we want to figure out if we're sliding? Because if we just do a sweep down, the object that we are resting on this one might be a little bit more difficult than I originally thought. So I'll be right back. Because sliding is not as simple as let's just check the normal we're on, right? Because our surface could look very different from what we expect. It could look like this. So when we sweep our object down, the first point of impact could be, you know, any of these slopes of things. We wouldn't actually know that we're on like a jaggy sawtooth thing, and well, because we're on these two things here, we're actually stable and we should be able to move over it or whatever. We could also be in a situation like this where our object is in a seam and it's fine. Like there's not a problem. So for us to actually be on a surface that we can slide down, we need to do a sweep down. The normal has got to be steep. So again, we got to pull out our notes here. We need to be able to slide down slopes that are too great. So there's a couple ways we could do this. We could just have it do it right now, just exactly as it is. And basically what happens is, you know, we're not sliding, and the reason we're not sliding is because we want to add to our z velocity, we want to add to our current velocity by the slope of the thing that we're currently on, and then we want to actually like try to move in that direction. So what exactly does this mean? Because we could do sliding with like, okay, let's see if something's under us. Okay, let's check the vector. All right, let's see if we can slide in that direction. Okay, let's slide in that direction. Or we could just apply a velocity in that direction, and what's going to happen is if we're standing still, our character would naturally start to slide down a slope, and if they could slide down that slope, they would just start sliding. So why don't we just see how that looks. So you are on the ground, and we're just gonna add like a let's see, it's gonna be like G slope to start sliding Z, and that's going to be basically let's set it at like 0.9. So you're going to start sliding nearly immediately, and let's set a like a slope slide friction, not a slope slide friction, but a slope slide gravity. Or we could just use gravity. We're not going to though, because we might need to tune a few things here. Okay. Because I just thought back to what I was saying before, and I was like, oh, well, we'll be able to do sliding just by messing with our character and adding in velocity. All that crap. And I was like, well, that's not wrong. Because basically what we can do is we can when we're on the ground right now, how are we setting our velocity? We are setting our velocity is just equal to our wanted velocity. And what we actually want to do is we want to set our current velocity towards our wanted velocity, but we want to like adjust it. So like if the slope is greater than a certain amount, we actually want your velocity to, like if you're on flat ground, we want to approach your wanted velocity very, very quickly. It's like a force you're able to exert on the character. And right now it's infinite. It's like boom, you're going your speed. And of course we don't want that either. We want, you have to actually speed up to that velocity. And our velocity is going to be normal to the surface regardless of what we're doing. So we have the surface normal, movement direction vector. So if the movement direction vector well, do we have the collision normal? We have the impact normal. Alright, well, let's just play around. So if impact.z is less than our slope to start sliding z, then what we're going to do is we are going to add to our velocity so it's going to be current velocity, movement direction vector. Movement direction vector is rotating Are we even using the current velocity for anything? Just the movement distance for sweeping after? Current velocity is already in this direction. We need to kind of fundamentally change how we're doing this. We don't want the wanted velocity dot y, do we? We want like the wanted velocity. Yeah, we do want it. It's we basically want to. Well, we can just play with this. The current velocity is going to be. We want to add the movement direction vector plus equals movement direction vector times delta t times slope gravity. And this is dot z. Alright, well, we'll see. I'm gonna have to do a lot of little, like the air control all has velocity built in, but the ground control does not have a nice velocity built in. It's just like hard coded to you, like you're moving at the speed that we are setting, and that's a bit of a problem right now because I don't have any easing. I don't have any like. I want to go towards the speed of 3,000. It's just like you're at speed 3,000, and I need to figure all that out. It's really not that much work. It's just I've been coding for almost 8 hours, and you start to just get with vector math. Yeah, see, look at that. He's starting to slide. Well, he was. And then he's standing on something, isn't he? The movement direction vector is up in the y and way up in the z. So yeah, this is another one of those where we're standing on a tiny little thing. So our impact normal is not very good. It's happening pretty much because of these seams in these objects. You'd have to make sure that every single one of these seams doesn't exist. Which is not the worst thing ever. Like, going and doing that for all the surfaces is not too tedious. Like, it's one of those things that you kind of get used to. You're like, okay, all of these things have to be just a little bit, you know, a little bit out from each other. And you'd also be doing this on a kind of a smaller scale than what I'm doing right here. Especially in like art. Certain things will look a certain way, but they'll actually have collision that's a little bit different. And it's not too unexpected for that in games to have a little bit of fakeness going on. And is that the kind of sliding that we really want? Is the other question. The other thing is I could probably also just like nudge out a little bit and down, and that way we. So for the impact normal, I would actually like grab a separate thing here. I'd have a test and do something like if, you know, the impact normal is because this Z was kind of up, so it was like ow. I should probably just do like a vertical nudge thing, so basically have two positions and have like collision 2. And you take two different positions. The second one, like this would be test position. So it'd be like effector test position. It'll be like if the sweep down worked. Then we're gonna test by it's gonna equal start position plus the impact normal times like this ground vertical nudge. What is this? Yeah, it's alright. We'll pass in collision 2. and we do if collision 2 happened, then we are going to compare the normals. So we'd say like if collision 2 dot hit dot impact normal does not equal collision dot hit dot impact normal, then we're going to set collision dot hit dot impact normal equals collision 2 dot hit dot impact normal, or whatever. Well, I might say like slide normal. Well, this wouldn't just be the slide normal, this would also be the movement direction. So this would be F vector movement normal. And we'd say like movement normal equals collision 1 hit impact normal. And we'd say here this is the collision 2 hit impact normal. That'd be the movement normal, and we just do this. Let's see how that works. Because this is basically, we take that thing, we do a little bit more work. Let's see if there's a different surface to be on. It might work. It's basically what we're working around is that reality in this thing is not what we actually want to measure against. We're trying to fuzz it up. After being, we need to be really precise on some things, and we need to be really fuzzy on others, which is difficult. So the impact normal for collision 2 was such, and the impact. So this is the negative y, and the other one, and then the impact normal for collision 2 was actually z1. Wow. All right. So the impact, the movement normal here is this one. Looks like what we want to take is maybe the steeper of the two. So the one who has more in the z. So why don't we just do that? Let's see, like if they don't equal each other, we're gonna say if collision 2 dot hit dot impact normal dot z fmath abs that is less than movement normal dot z else. Because all of a sudden these movement normals have to like actually be good on this slipping and sliding crap, which is not what we've needed so far. So that's why because we've just been sticking to the ground, right? It's just like I'm on the ground, no problem. So let's see, what is the movement normal here? It's collision 2 is the collision, the hit, yeah. The hit impact normal is 1. What was the collision 1's impact normal? So moving up in the Z. What was the collision distance? The ray distance was, the collision distance was nearly on top of us. I got a normal of 1 on the Z. That's not possible. So it's start position plus, so we're going straight up by a very small amount. We're again going down. Well, let's actually do ground, G ground test nudge. And let's do that. And let's move ourselves out by quite a bit. Let's actually move ourselves out by 1. Because there's nothing there that we should be colliding with that has a normal of 1. Because we're on the slope. Like, the only thing that's got a normal of 1 is like, it would only make sense if we were inside of the object and it can't get the normal, it's just like a default value or something, so. We will see. We will see shortly. Oh man. Sorry, just looking at the Cavs versus the Raptors game, and the Cavs are just making them look like chumps. Alright. So there we go, we're sliding in that little flip there is the thing that's screwing us up. So the question is, what exactly can we do about that? Because we're colliding with our sweep down, and then our impact normal, we've moved ourselves up. And we're still sweeping down, we're still getting the same impact normal. Now, what is the distance for hit 2? Because it's going to hit, right? Yeah, it's going to hit. And collision to hit distance is 1. So we hit something correctly. The normal, though, is not correct. So we actually want to like move to the left or to the right for this thing. So why don't we just do like plus, yeah, we'll just do like test position dot y plus equals like the ground test nudge. Let's see. Probably, like, we've already moved ourselves up. We probably want to do like collision 3 as well. So we kind of want to like do 3 sweep tests for our box and just like take the one that's the best. So we'll just do that real quick. So just kind of, we'll move up. We'll kind of just move up and to the left and to the right and sweep down, and we'll see if that solves our little sliding problem at all, because we'd like a normal there.